questions? You can stop me anytime if you have anything. If not, we're going to continue with, we are still in 4.5. We're continuing with exponential growth model. It will be given to you. You don't have to memorize it. It's A of t, A0 e to kt. Let's see what these mean one more time. This is amount. This is initial amount. It can be number of fish, number of people, number of bats, rats, mice, whatever you want, bacteria. And this is the exponential growth rate. Growth rate. And this is time. Okay, so let's look at an example with the exponential growth model. Problem 8 on 529. In the year 2000, we take notes when we read. The population of the Palestinians in the West Bank, Gaza Strip, and East Jerusalem was approximately 3.2 million. By the year 2050, it is projected to grow to 12 mil. Use the exponential growth model, in which t is the number of years after 2000. T, number of years after 2000, which means 2000 represents, excellent. To find the exponential growth function that models the data. That's part A. And then we go back and read part B. So I look at the information I'm given. 2000, 3.2, to 2050, 12. What is this? What am I given in this problem? Yes, points. I'm given 2 points, but I cannot use this and I cannot use this, but I know that this is t equals 0, and then this must be t equal 50. So can anyone give us one more time the ordered pairs? And remember, you have to put the first coordinate, the independent variable, and the second coordinate, the dependent variable. And you can never consider time being dependent on anything, ever. So if anything involves time, that's the independent variable mandatory. Yes, 0, 3.2, and that's it. I'm going to copy the model. So A of t equals A0 e to kt. And I want 2 equations from you. Plug in the model the first point and get 1 equation. And plug in the model the second point and get the second equation, please. Can anyone explain what does the first point say, or second point? Just tell me the idea. When
2000.
When t is, A of t is, or A of 0 is, yeah, that's it. When t is 50, A of 50 is, that's it. I would like you to put those 2 points and tell me what to write. First equation for the first point.
3.2
Equals A0 times e to k times?
0.
Excellent. In the same way, I would like to see the second equation.
12 and 0.
Times? Excellent. So now let's take it slowly and see what the first one is telling us and see what the second one is telling us. Ready? Okay, how much is k times 0?
0.
How much is e to 0?
1.
Excellent. So from here, I already know that A0 is 3.2. You can say, did you really need this equation? No. but I want to establish what the equation or what the point is giving us. But yes, it would have been very clear from the very beginning, after t equals 0, 2000, t equals 0, obviously this must be the original population or where the study started, the initial value. But this is more important to be able to put in an equation. It's more important than just saying, oh, I see the A0 is 3.2. Okay, so now I will plug in 3.2 here. So the second equation actually becomes 12 equals 3.2 times e to 50k. So let's go back to the model for a moment. Obviously, this is the function, or the y. This is unknown. This is the independent variable. This is unknown. So as long as I have determined these two, I determine the model. So for now, I have this, but I don't have that. But from the second equation, and replacing A0 by 3.2, I would be able to find the growth rate. Okay, so how do I do that? Yes? Yes, absolutely. That's the first step. Great job. And then, yes, what should I do to both sides in order to get rid of the exponent? Exactly. So then natural log of 12 over 3.2, do not divide, there is no point, equals 50k. But I should write 50k times natural log e. But how much is natural log e? Why don't I write natural log e? Because natural log e is exactly. I hope that this doesn't smell. I'm sorry if it does. I had some soup in there. My apologies. Okay, so then k equals natural log 12 over 3.2 divided by 50. So let's put it in the graphing calculator. Oops, sorry. Okay, so natural log in parentheses 12 divided by 3.2 close divided by 50. Normally we need 4 decimal digits at least for the growth rate or decay rate, it doesn't matter. So k equals 0.0264, at least 4. 4 is enough, but you know what I mean. Okay, so now we have the model. Everything, we know everything about this function. E to 0.0264t. This is it. Part B, and I will invent a part C in a second. In which year will the Palestinian population be 9 million? So what am I trying to do? Of course, this is population and this is time, since number of years since 2000. So 9 million, this is part B, this is part A. 9 million equals 3.2 e to 0.0264 t. So we want to know divide by 3.2, so 9 over 3.2 equals e to 0.0264 t. And then, of course, like a minute ago, we apply natural log to both sides. We have no other way. And this is natural log of 9 over 3.2 equals 0.0264 t. And of course, we divide. Natural log 9 over 3.2 over 0.0264. And when we do that, I have natural log 9 divided by 3.2. and divide by 0.0. I have it right here. I'm too lazy to type it up. I'm going to just call the previous answer. So it's roughly 39. 39 what? Yes. Which means roughly which year?
2039.
Okay, I'm inventing part C. It's a very important question. They should have put it in themselves. Here's my question. When will the initial population double? When it will double? How do I solve this?
You put in 6.4.
Absolutely. 6.4. It's 3.2 e to 0.0264 t. Indeed.
Oh, you want this?
No, I was just going to say to Becca to team up with you and we can teach this class next semester. I don't have to do anything.
Oh, it's gotta be what I'm not doing. Because I'm not.
I mean, I can sit down and take a nap. I don't want to record this, but one of my colleagues gave, this was years ago, gave an exam and fell asleep. He got fired.
Oh, well,
But I think it was, he really had a medical condition. I don't think it was, okay, it was some time ago. So we divide, so we get 2 e to 0.0264 t.
each dwarf and Snow White had a mental condition.
Say it again.
Each dwarf and Snow White has a mental condition you can break it down to with a CP.
Natural log 2, 0.0264 t. So t equals natural log 2 over this. So this will give us the number of years since 2000, right, needed for the population to double. And how much did we get?
26.
If you have it, don't torture me. So t is at 26. So in 2026, assuming peace is on Earth, which I hope for everyone, in 26 years, the population will double from 3.2 to 6.4. Okay, any questions on exponential growth model? We'll have more problems. Why not? Let's take a look at this. Since we are here, since we're doing this, page 6 out of 13.
Well, if we're gonna do the extra credit.
The extra credit, yeah. Why not? We all have this form.
Yep.
I have a few left over, so if you don't find it or you don't have it, let me know. Garrett, do you have it?
I'm still looking. I think it's right now.
Okay. Good, so let's read
Yes.
the problem. Perfect. So let's read this. Exponential model, blah, 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 describes the population of a country in millions 2 years after 2003. Use the model to determine when the population of the country will be 733 million. 1 minute. And I'll take attendance in the meantime. Of course, I'm logged out. What happened to Victoria? She never missed class. Chris, Gary, Logan back. Okay, perfect. Okay, do we have a number? We don't? We need more time? I'll wait, I'll wait, I'll wait, I'll wait. I just want to write the model. A of t equals 543.3 times e to 0.02 t, and we want 733 to be 543.3 e to 0.02 t. So that's the exponential growth model. You will have to do what first? Right. Yes, getting ready to apply natural log. Natural log, natural log. So natural log 733 over 543.3 equals 0.02 t. So therefore t if you have this number, again, don't torture me, please.
14. It's 15, so it's about 2018.
15, so approximately 2018. So what have we learned about this model? Right, the initial value, the initial amount may be missing, the growth rate may be missing, but from the given information, we should be able to determine the initial amount and then determine the growth rate. Any difficulty here? Okay, so the exponential decay model is identical with, I shouldn't say identical, it's very similar, but it has a minor change, minor difference, right? So the exponential decay is the last model. I like to use mass for exponential decay. So this is mass, the initial mass times e to negative kt, where t is time, k is the decay rate, m0 is the initial mass, and m is the mass at time t. Of course, you can use a of t as well. It doesn't matter. So when it comes to a radioactive substance, we know radioactive substances decrease their mass in time. And this is for radioactive substances. But if it's a number, bacteria or something else, you can use this. Does it matter? Absolutely not. Use the model you like. Use the letters you like. I don't mind. So let's take a look at an exponential decay situation. 32 on page 530. Okay. A bird species in danger of extinction has a population that is decreasing exponentially. Decreasing exponentially. 5 years ago, the population was 1,400. Today, 1,000 birds are left, are still alive. Once the population drops below 100, the situation will be irreversible. No one can save the species. I hope that's not the case. But we want to know when will this happen, so maybe we can take action and prevent that from happening. What is given in the problem? We are given two
Sets of points.
very good. 2 sets of points or 2 points or 2 coordinates, yes. 2 ordered pairs with their corresponding coordinates. Obviously, time is the independent, so this will be 1,400 and this will be 1,000. That's the dependent variable. So what I recommend, consider 5 years ago 0, and today, exactly. Instead of having a negative time. So let's say we started counting 5 years ago, and that's our initial value 0 at 0 times 0. Today, 5 years later, we read this. So 5 years ago we read this. Today we read this. And I do have a couple of a family, husband and wife. He was my colleague here for 33 years in the math department. He retired 12 years ago. And they are involved in birding and counting birds for more than 42 years. They're in their 70s. And they do counting every year. I have no idea how they count, to tell you the truth. How can you count birds? But I think they have a certain territory, and potentially, I'm assuming now, without knowing, that birds are kind of territorial like other animals and other species. So they go to a certain square that it's assigned to them, and they count. It's amazing. It's an amazing couple. I think they have at least 200,000 slides of birds. At least. He gives talks all over the place. It's amazing. Amazing couple. Okay, so number one, we're asked to find a model, right? So by finding the model, we mean find this and find this. If you have these two numbers, then you're done. You have the model. That the information, that the model that is based on the information given in the problem. So I need to determine this, which we kind of know, right? And then we have to determine that, which is the decay rate. This population is not increasing, but decreasing at a certain rate. Okay, so what do we do? We have to write an equation for each point. Slowly but surely, please give me the equation for the first point. 1400, excellent, equals the initial. Let's say we don't know what the initial is. Times e raised to negative k times. Perfect. Leave it alone for a second. And let's write the second point. Yes. Equals the a0, which we don't have just yet. Excellent. That's it. Once we understand this, that's what the point is telling us. That when time is 5, a of 5 is 1,000. When time is 0, a of 0 is 1,400. And that's exactly what we put in. So obviously the first one is very clear because negative k times 0 is 0 and e to 0 is. So obviously we knew this. We knew this, but we are just practicing. So this goes into the second equation. 1,000 equals 1,400 and e to negative 5k. And obviously now in the second equation, with the second equation, once I solve the second equation, I have k. But how do I do it? Right. I have to get rid of 1,400. So this is 10 over 14 equals e to negative 5k. So far, so good. Next, I must apply log. Very good. Can you apply common log? Yes. But if you apply common log, you're going to have another number, like log e. You don't want that. Since the base is e, always apply natural log. If the base were 10, I would have not applied natural log. I would have applied log 10, or common log. So natural log 10 over 14 equals negative 5k. So k equals natural log 10 over 14. Remember to put a negative 5 in the denominator in parentheses. So natural log 10 divided by 14. And divide everything by negative 5. And I got 4 decimals. You can even keep 5 for this one. So k equals 0.06729. Now we have the entire model. And now we can answer any question. So we have a of t equals 1400 times e to negative 0.06729 t. There are no more unknowns in the model. The unknowns were the rate, k, and the initial value, which we have. Part B, once the population drops below 100, the situation will be irreversible. When will this happen? For what? Yes, of course. Yes. Yes. Of course. The population is 100. So let's see how long we have. Potentially, hopefully, we can save the species. So of course, I will divide e to negative 0.06279 t. And then natural log of 1 over 14 equals negative 0.06279 t. How many? 42 years. So we should get on it and train other people to help the species recover. Very good. So this is an example of the exponential decay. I want to ask a question now here. I'm adding a question. How long it takes for the population of birds of this species to no. No, because it's the other way around. Now it's decreasing. To become no. To become half of the initial number.
I think we're just being random.
So, because this is something connected to what's next. I don't want to say it yet. I don't know what to say. Yes, exactly. The half-life, of course. So, how long it takes this population of birds to become half of the initial size? Exactly. Very important. It will save me some time in the next set of problems. That's why I'm asking that question. Yes, so 700 equals 1400 e to negative 0.06279 t. So we started with 1400. We want to know how long it takes for the population to half. Okay, so I don't really need to divide by 1400 because I know this is 1/2. It must be. 700 over 1400 must be 1/2. So this is e to negative 0.06279 t. We apply natural log to both sides, and we have natural log of 0.5, negative 0.06279 t, and t is natural log 0.5, negative 0.06279.
This would help me out so much in high school when I had to pass chemistry.
You said this would have helped you.
Yeah.
Understand. Okay. Well, I'm sorry I wasn't there for you.
I remember now, last question, I had no idea if I had to do the half-lives at that point.
Sorry.
It's okay. I'll invent time travel. I'll be able to go back and fix myself and take care of that problem.
If you could time travel, you're going back to chemistry.
Shoot.
Special ways.
Hey, that could change everything.
10 and measurement unit. So it appears that the population, it becomes half in 10 years. Yes, please.
What am I entering wrong?
I have no idea.
I got 11.
Consider causing this.
You may forgot to put parentheses. I don't know if it makes any difference. If you don't put parentheses, this may change. I don't know. No, it doesn't. So it's natural log 0.5 divided by negative 0.06279.
6, 7, 8.
I'm ready.
Okay, so that's what happened. You rounded up, and I was too lazy to.
No. It's
No,
6,
it's
7,
the
2,
number.
9. That's 6, 2, 7, 9.
If I put in that whole long thing,
I copied the previous answer.
I can live with that.
So I'm closer to the solution because I used the whole thing without truncating it. Would I deduct points if you write 10.11? No. Somewhere in that range. Okay, so we started with 1400. In 10 years, we did 700. In 10 more years, how much will we get?
0.
One more time. We started with 1400. In 10 years, 700. In 10 years,
It's 35.
in 10 more years, 125. 175. So this is what we call half-life. So the half-life of this population is 10 years. Sorry. The half-life of this population is 10 years. No matter what amount we start with, if we start with 10, in 10 years we get 5. In 10 more years we get 2.5. In 10 more years we get 1.25. And 10 more years, half of 1.25. So all I wanted you for now is to understand the half-life. So if we have 100 milligrams of a radioactive substance that has half-life 2 years, and we start with 100, in 2 years we have 50. In 2 more years we have, and so on and so forth. Okay, good. We are ready for problem 30. That's the meaning of half-life. 30 on page 530. The half-life of aspirin in your bloodstream is 12 hours. Aspirin. So assuming I take an amount, I don't even tell you, I don't even know what it is. I take M0 grams or milligrams of aspirin. In 12 hours, what do I still have in my bloodstream?
Half of that.
Half of M0. Okay, in 12 more hours, what do I have? Yes, and so on and so forth. Is that clear? Perfect. Good. Next. How long will it take for the aspirin to decay? Not to 50%, not to 30 or 20, but to 70% of the original amount. How long is needed to decay the original amount to decay to 70% of the original amount? To 70% of the original amount. Since we are talking about mass, I recommend this notation, but it doesn't matter. Mass at time t equals the initial mass e to negative kt. And of course, m is the function, t is the independent variable, and we do have two unknowns here. One unknown is this, I don't know how much I took, and the other unknown is, I don't know the decay rate. So in order to be able to determine this, I have to come up with a model. I have to think of this, and I have to think of that. But I do have one piece of information, which is this. What does that mean? Which point is that? Let's think for a moment. So I start with M0, and 12 hours later I have m0 over 2. So give me that point.
So,
Comma,
half.
yes, of whatever initial it was. The initial was m0, 12 hours. Yeah, later I have m0 over 2. Please plug this point in the model. If you understand that, then 95% of the battle is won. And that's what we've been trying to do this all day. This thing to clarify this all day. So please plug in the point in the model. Yes? Yes.
Equals 12. Natural log.
No. This is T. This is T. This is that. E to negative K times 12. So T is 12, M of 12 is M0 over 2. Okay. I still see two variables. Not really. Let's divide both sides by M0. I divide the right hand side by M0. I divide the left hand side by M0. I get 0.5 on the left, E to negative 12K on the right. And that's all I need to find K. So natural log 0.5 equals negative 12K. So K equals natural log 0.5 over negative 12. And let's see how much is K. I got natural log 0.5 divided by negative 12. And use 5, approximately 0.05776. So I have the model, and you can say not really, you don't have M0. I don't care for M0. So A of T, M of T equals M0 E to negative 0.05776 T. Okay, so now the question. How long it takes for what I took to decay from 100% not to 50, but to 70% of the initial value. Here we had 50% of the initial value, but now I want 70% of the original or initial value.
Initial value times 0.7.
That's it. So 0.7 times M0 equals M0 e to negative 0.05776 T, indeed. Of course, who cares about the original value? We don't even need it. We divide both sides by M0, and then we have 0.7 equals e to negative 0.05776 T. And of course, we apply natural log to both sides. And we get natural log 0.7, negative 0.05776 T. Natural log 0.7. When you get the chance, I'm not saying you always have to do it, but if it's possible, if the previous answer has that number, use it, use the whole answer. It's okay if you don't. See, I already have this rate in there, so I will put natural log of 0.7, close the parenthesis, and divide by the previous answer. But remember, you have to put minus. So minus the previous answer, and close the parenthesis. And it uses the entire number, which means no approximation. Oops, oops, oops. Okay, so I got approximately what? 6 hours. Approximately 6.17 hours. So if we take the aspirin right now, we still have in the bloodstream about 70% of it in about 6 hours. In 6 more hours, we are down to 50%. Okay. Any questions on radioactive decay? Any questions on radioactive decay? Do we need another example with radioactive decay? We had two, one with birds and the other one with mass. Yes, yes. Let's look at 29. In 29, we have the half-life of lead. Oops, 22 years. Half-life of lead. How long will it take for a sample of this substance to decay to 80% of its original amount? So we have lead. It decays in 22 years. So if we start with M0 now, in 22 years we have M0 over 2. How long it takes for any sample of this substance to decay to 80% of the original amount? I have to write the model. You do not have to memorize the model. The models, I will put the models in all functions, in all problems. So since it's mass of T equals M0 e to negative KT. You will get this. It will be part of the problem or the text of the problem. So then, how do I start? Yes, so 22 years, M0 divided by 2. So, oops. M0 divided by 2 equals M0 times e to negative K multiplied by, that's it. So the left-hand side is 0.5. The right-hand side is e to negative 22K. From here, we want to find K. We will apply natural log to both sides. So we have natural log 0.5 equals negative 22K. Losing my voice.
And the cap.
They go together. You can't lose your voice without losing the cap. Okay, natural log 0.5 over negative 22. You just don't want to step on it. So let's see what we get. Natural log 0.5, close the parenthesis and divide by negative 22. In parentheses, please. So I would take maybe more than 4 decimal digits. So K is approximately 0.031506669. Okay, so we have the model. So the model is M mass of T equals M0 e to negative 0.031506669 T. You saw how small was the difference between your medicine, your round up the K and not rounding up was almost a year. Yeah. So it makes a huge difference. Another decimal digit, yeah. Okay, so now we want to determine the time needed for M0 to decay to 80% of it. So how do I write this? Yes, but I have to write the point first. Yes, 0.8 M0 equals M0 e to negative 0.031506669 T. I get rid of M0, nobody cares. We don't really need it. We're not going to use it. And please give me time. So natural log 0.8, negative 0.031506669 t, and t will be
7,
roughly 7 point,
0, 8.
okay, 0.1 years. Very good. Any questions? Good. Now we had enough problems, I think. However, if you don't go back and practice, you will not remember it, right? So please finish up homework and everything, okay?
I found my answer recall them, so
Excellent.
we're great.
Excellent. Very good. Systems of equations. 5.1. Two variables, two equations. We're going to review substitution and elimination. Let's look at an example. So again, I just want you to know where we are. So we're going to attempt to do whatever we can from 5.1. 6.1, I would probably leave at the end after 5.4 and 5.5. Because 5.1, 5.4, and 5.5 are very similar. 6.1 is not. That looks differently. It's still the same, but it looks differently. So we'll see what we can accomplish from 5.1 first. Okay, so I'm going to select number 8 on page 555. 2x minus 3y equals negative 13, and y equals 2x plus 7.